When the bleep are we going to use that?
Welcome back. Today we are talking about graphing inequalities. To truly understand this skill, we need to go back to the basics. We graph inequalities on a number line. So let's look back at number lines. All real numbers can be found on a number line in numeric order from smallest to largest. You can think of a number line as 2 yards with a fence between them. Negative values are on the left. Positive values are on the right. 0 is the fence in the middle. It is neither negative nor positive. We call this a neutral value. 0 acts as a great reference point. The further that you go to the right, the greater the value. The further that you go to the left, the lesser the value. When we plot a value on a number line, we follow a few basic steps. Locate the isolated value on the number line. Mark it with a point. This isolated value is given to us as the variable is already by itself. Since these are technically equations, this value is our solution. I find the negative 4 on the left of the 0 and mark it. If the value is a decimal or fraction, round down and round up to find the integers that the value is located between. If I were plotting negative 3.2 on a number line, I would round down to get negative 4, since less is more with negatives, and round up to negative 3. My answer must be between negative 4 and negative 3. These two integers will be my reference points. It has to be between these two integers. Then I estimate the correct position between the two integers. 0.2 is close to 0.25, which I know is a quarter of the way. So I plot my point about a quarter of the way, which is closer to negative 3 than negative 4.
I want you to try this problem. Remember to show all your work.
An inequality is a comparison between two values or algebraic expressions that are not equal to one another. Many of you have probably learned the alligator or crocodile method for inequalities, where the alligator eats the bigger value. The problem is, alligators and crocodiles are vicious killing machines who mindlessly eat things of all sizes. Less than,
Come and get it!
greater than, equal to. Although this method works for comparing values, there's more to inequalities than that. If you rely too heavily on this more elementary application of inequalities, you'll never advance your understanding and mastery of inequalities, and that never ends well for anyone. We are no longer dealing with equations, and although we will eventually keep the same balancing rules intact, the values on either side of the inequality are not equal to one another. When you compare values, they can either be equal to one another, greater than one another, or less than one another. We've already worked with an equal sign before. This is what we saw in equations. The greater than symbol looks like this, and the inequality would read 4 is greater than 2, which is a true statement. 4 is indeed greater or bigger than 2. You can remember the symbol because the greater than symbol looks like part of a G in the words greater than. The less than symbol looks like this, and the inequality would read 2 is less than 4. You can remember the symbol because the less than symbol looks like the L in less than. Sometimes there are solutions that can be equal to as well as less than or greater than because inequalities have a set of solutions, not a single value solution like equations. We call these inequalities less than or equal to and greater than or equal to. Notice that they are a mixture of the less than, greater than symbols and the equal sign. The marked off area represents compound inequalities, which we will cover in another lesson. When you plot an inequality, you have to plot the isolated value Identify where all possible solutions are located using arrows, which we'll discuss in a moment, and identify if the value is a solution. We do this by using different forms of points. Greater than and less than are both plotted with open points because the isolated value is not included as part of the solution. It's just a starting point for graphing. Less than or equal to and greater than or equal to are plotted with closed points because the isolated value is part of the solution, which means if you plugged that particular integer or value back into your inequality, you would get a true statement. To graph an inequality, start by plotting the isolated value on the number line using an open or closed point depending on the type of inequality that you're dealing with. In this case, we have x is less than or equal to 3, so I plot a closed point. If it was just less than, it would be an open point. I plot it on the 3 on the number line just like we did when we went back to the basics. Next, pick a value on the number line and substitute it in for the variable. I like to use 0 because I know that it is greater than all negative integers and smaller than all positive integers. It gives me a very easy reference point for our next step. However, you can use any value that you'd like. I substitute this value in as if I were checking my answer. If you get a true statement, the arrow points at the substituted value. If you get a false statement, the arrow points away. In this case, 0 is in fact less than 3, since all positive integers are greater than 0. So I point my arrow from the plotted point towards 0, and I continue past it to the end of the number line. If I got a false statement, if 0 was not less than or equal to 3, then I would point away, and all my solutions would be to the right. We graph our inequalities this way because it shows us where all of our solutions are located. Inequalities do not have one solution like equations. In this case, all values to the left of 3 are solutions and could be substituted into the inequality for a true statement, including 3, since it is less than or equal to. If I plugged -5, for example, it would give me a true statement. -5 is less than or equal to 3. This is true. If I plugged in +5, I would get a false statement. 5 is not less than or equal to 3. This is a false statement. This is why it's on the side of my plotted point that does not have an arrow. It's not a solution. Some students like to use the arrow shortcut and assume that the direction of the arrow is the same as the inequality. This method does not work for all scenarios and can lead to errors and frustration. If you rely too heavily on this more elementary application of inequalities, you'll never advance your understanding and mastery of inequalities, and that never ends well for anyone. Let's try a couple of problems together. Start by plotting your point. -2 is greater than or equal to x, means that we will have to plot a closed point on the -2 integer. The location and type of point are very important. This is a closed point because it's greater than or equal to. If it was just greater than, it would be an open point. I chose plot on -2 because I have -2 as my isolated value. Pick any integer and substitute it into the inequality. In this case, I used -10. -2 is in fact greater than or equal to -10. That's a true statement, so we point our arrow from the plotted point towards the substituted integer. In this case, -10 is left of -2, so I point to the left. All values to the left of -2 and including -2 are solutions to this inequality. If you struggle with true or false statements, compare the substituted integer and plotted point. Whichever one is on the left is less than. Whichever one is on the right is greater than. If that doesn't match up with your inequality, it is false. For the next problem, let's start by plotting your point. X is greater than 9 2/7, means that we will have to estimate where we plot our point. If I round up, I get 10. If I round down, I get 9. 2/7 is about, if I had to estimate, about 1/3 of the way between them, but closer to 9. So I plot my open point there. The location and type of point are very important. This is an estimation. You just need to be in the right neighborhood. Pick an integer to substitute in. I like 0 because it gives an easy frame of reference. When I substitute 0 in, it's clear that 0 cannot be larger than any positive value. In this case, 0 cannot be larger than 9 2/7. Since I have a false statement, I'm going to start at my arrow start at my plotted point and point my arrow away from where the substituted value is. So in this case, I'm going to point away from 0 to the right. All values to the right of 9 2/7, but not including 9 2/7, are solutions to this inequality. This means that even though we plotted our point at 9 2/7, we would get a false statement if we substituted 9 2/7 back in.
I want you to try this problem. Remember to show all your work.